Let's talk about some of the basics of electrochemistry. So electrochemistry basically involves redox reactions where you have the transfer of electrons between two different species. So if you undergo oxidation, you lose an electron. So here's an example of a solid lead dissolving and becoming lead 2+, and losing electrons to solution or to a circuit or whatever. And if you are undergoing oxidation, you are also the reducing agent and the reductant because you give off electrons. So if you're undergoing reduction, you're gaining electrons, oxidizing, and that's also called the oxidizing agent or oxidant that takes electrons. And so here's an example of a copper 2+ gaining electrons to form a copper 0 solid. And these both have potential energies associated with them, which we're going to talk about a little bit more later on. So first, before we can start getting into too much detail, we first need to go over some basic definitions. So we define charge, which has the symbol Q, as either being a coulomb, there's a coulomb. A coulomb has 1.602 times 10 to the negative 19 coulombs per electron. And you can also have a charge of a Faraday. That's another unit, and that's 9.649 times 10 to the 4th coulombs per mole. You can also talk about current, which is measured in amperes, which is 1 coulomb per second, and that's a quantity of charge that's flowing through a circuit. You can also talk about a potential difference, which is measured in voltage, and that's basically the push or pull to move a charged particle. You can also talk about resistance. That's measured in ohms, and that's 1 amp across 1 volt, and that's sort of a measure of friction, or how much resistance you're encountering. So here's an analogy that I think is kind of entertaining. If you want to talk about current, it's basically like how many people are moving down a street. So I think about the New York Marathon, where you have a ton of people trying to fit down this little tiny street. And then you can think about the potential difference as being either running uphill or downhill. And maybe the resistance is like trying to get forward, going forward when you're sort of crowded in by all these other people. Yeah. So here's some useful relationships in electrochemistry that you can use quite a bit. So work is defined as the potential energy times the charge, and that's measured in joules, which is a volt times a coulomb. You can have negative delta G is defined, delta G is defined as negative work, which is equal to negative N, the number of electrons, F, the Faraday, times the potential difference. Ohm's law is E equals IR, or the potential difference equals the current times the resistance, and that's Ohm's law. You can also say power is defined as work per second, and that's eventually you can make that the same thing as current squared times resistance. And that's measured in watts, which is joules per second. So that's all for the introduction to electrochemistry.